I'm Dr. Binu. In Artificial Intelligence and Machine Learning Fundamentals, the third topic in the fourth unit is backpropagation in neural network. Backpropagation is also called as backward propagation of errors, which is a method used to train the neural network. The goal of backpropagation is to reduce the difference between the model's predicted output and the actual output by adjusting the weight and biases in the network. The diagrammatical representation of backpropagation neural network is represented in this diagram. Here, like a neural network, it consists of input layer as well as hidden layers as well as output layer. This output is the predicted output. Suppose if there is a error between the actual output and the predicted output means which is that error is sent back to each neuron in backward direction. Actually, the error is a difference between the predicted output and the actual output. Here, the gradient of error is calculated with respect to each weight. The adjustment of weight is done through backpropagation. This illustration shows how the backpropagation works by adjustment of weights. The backpropagation often uses optimization algorithms like gradient descent and stochastic gradient descent. The algorithm computes the gradient using the chain rule from calculus, allowing it to effectively navigate complex layers in the neural network to minimize the cost function. The working of backpropagation algorithm. It can work in two steps. The first one is forward pass. The second one is backward pass. What will be taken in the forward pass means that is in forward pass from the input layer, then the data is given to hidden. After that it reaches the output layer. What is backward pass means? In the backward pass, the error is propagated back through the network to adjust the weight and biases. One of the common method for error calculation is mean squared error, that is MSE. The formula for the MSE is the square of the differences between the predicted output and the actual output. The forward propagation, the weighted sum at each node is calculated using the formula Aj is equal to summation of Wij into Xi. Here Aj is the weighted sum of all the inputs and weights at each node. Wij represents the weight between ith input and the jth neuron. Xi represents the value of ith input. What is meant by sigmoid function? Sigmoid function returns a value between 0 and 1, which introduces the non-linearity to the model. The sigmoid function is represented by y of j is equal to 1 divided by 1 plus e to the power of minus aj. Fixed weight competitive net. Fixed weight competitive nets are simple unsupervised neural models where neurons compete and the one whose weight vector best matches the input is declared the winner. They are normally useful for fast classification, but they are lagging in adaptability. Fixed weight competitive networks are type of unsupervised neural network which is normally used in pattern classification and clustering. They are based on competitive among neurons. When an input is given, only one neuron wins and becomes active. The weights are fixed here. The fixed competitive networks, the weights are fixed only, which are not updated by learning algorithms like backpropagation. Classification happens by assigning inputs to the neurons whose weight vector is closest to the input vector. The working principle of the weighted nets. Each neuron has a weight which is predefined or chosen based on the problem domain. An input vector is presented. Then network calculates similarity between input and each neuron's weight vector. The neuron with the highest similarity wins the competition. That neuron represents the input pattern. The architecture consists of input layer, a competition layer, as well as output. The input layer takes feature vectors. Competition layers, here each neuron has a fixed weight vector. The output is the index of the winning neuron, which is normally a category or cluster the input belongs to. Example, suppose we want to classify fruits by weight and sweetness means neuron 1 represents apple with a weight vector of zero point 0.7 and zero point 0.6. Neuron 2 represents orange with the weight vectors of 0.3, zero point 0.6. Neuron 3 represents banana with the weight vectors of zero point 0.9 and zero point 0.2. If the input is 0.8, comma 0.25 means based upon the similarity, that is highest similarity, the output is chosen. That is the input is 0.8, 0.25. So the neuron 3 is very close or similar to the input neuron, that is 0.9, 0.25. So the neuron 3, that is the classification is the output is chosen as banana is the fruit which chosen by weight and sweetness. Applications are basic pattern recognition task, clustering unlabeled data, vector quantization, early models of self-organizing maps. Since here limitations, since weights are fixed, the network cannot adapt to new data. Second limitation is accuracy depends heavily on initial weight selection. A modern network often uses adaptive competitive learning, that is coherent self-organizing maps.